So here we're going to look at these three questions. So the first question is, a vehicle moving at 30 meters per second decelerates uniformly at 3 meters per second square. Full stop. How long does it take to stop? So the answer is 10 seconds. So let's solve to see if our answer will be correct. So the question again is, a vehicle moving at 30 meters per second decelerates uniformly at 3 meters per second square. How long does it take to stop? So the first thing we want to do here is to fish out our parameters. The first thing we want to do is to bring out our parameters. So first of all, we have that velocity, a vehicle moving at 30 meters per second. So our velocity is equal to 30 meters per second. Decelerates uniformly at 3 meters per second square. So the deceleration, our acceleration, which is negative acceleration, which is the deceleration, is minus 3 meters per second square. Deceleration means negative acceleration. So our negative acceleration is minus 3 meters per second square. How long does it take to stop? So initially the vehicle was moving at a velocity of 30 meters per second. So that means our initial velocity is equal to 30 meters per second. And then it decelerates uniformly at 3 meters per second square. So our negative acceleration, which is the deceleration, is minus 3 meters per second square. How long does it take to stop? So at the point the vehicle will stop, our velocity will now be equal to 0 meters per second. So at the point where the vehicle stops, our final velocity will be what? 0 meters per second. The question is, how long does it take? So the time it takes, how long will it take? So it is the time we're calculating, we're looking for. So from this question, the parameters that are given to us, we have u, we have acceleration, we have velocity, and we have time. So the equation of motion that connects all these parameters is the first equation of motion. And the first equation of motion is v is equal to u plus at. So my v is 0. My final velocity is 0. 0 is equal to my initial velocity is 30 meters per second plus my acceleration is minus 3 because the car decelerates, is negative acceleration. So I'll open a bracket for it, minus 3 times what? T, which is what I'm looking for, times T. So this will be 0 is equal to 30 minus 3 times T will give us minus T. So this will be plus, open bracket, minus 3T. So if I take this 30 to the other side of the equation, it will become minus. So this will be 0 minus 30 is equal to, plus times minus is what? Is minus. So plus times minus 3t will give us minus 3t. So 0 minus 30 is minus 30 is equal to minus 3t. So my minus will cancel out minus. So therefore my t will be equal to 30 divided by 3, and that will be equal to 10 seconds. So the time it will take this vehicle to stop is 10 seconds. So our answer is correct. T is equal to 10 seconds. Let's look at the next question that we have here. The next question that we have here is, a cyclist moving with an initial velocity of 10 meters per second accelerates at 2 meters per second square for 6 seconds. Find the distance traveled. Find the distance traveled. So we're given now, the answer is distance is equal to 96 meters. So let's solve to see if our answer will be correct. So a cyclist moving with an initial velocity of 10 meters per second. So the initial velocity u is equal to 10 meters per second. Accelerates at 2 meters per second. So my acceleration is equal to 2 meters per second squared for 6 seconds. Time for the acceleration is 6 what? 6 seconds. Find the distance traveled. So we're looking for the distance that is traveled. This is quite straightforward. So from the question we have the following parameters. We have u, initial velocity, we have acceleration, we have time, and we have distance. So what equation of motion connects these four parameters? It is the second equation of motion. And the second equation of motion is S is equal to ut plus half at squared. So my S, which represents the distance, is equal to my initial velocity is 10, my u is 10, times my t is 6 seconds times 6 plus half my a is 2 times 2 and then my t is 6, so times 6 squared, which is this t squared here, 6 squared. So my distance s is equal to 10 times 6 will give me 60 plus 1 times 2, so this will be 1 over 2 times 2 times my 6 square is 6 times 6, which will give me 36. So my S will be equal to 60 plus 1 times 2 times 36 will be what? 1 times 2 times 36 will be equal to 72. So this will be 72 all over 2. So my distance S will be equal to 60 plus 72 divided by 2 is what? 72 divided by 2 is equal to 36. So this will be 36. So my distance S will be equal to 60 plus 36. 60 plus 36 is 96 meters. This is the answer to this question. So the distance traveled, is what? 96 meters. Let's look at the last question that we have here. A car accelerates uniformly at 5 meters per second squared from an initial velocity of 72 kilometers per hour for 10 seconds. Find the final velocity. So this is quite straightforward as well. A car accelerates uniformly at 5 meters per second squared. So our acceleration is equal to 5 meters per second squared from an initial velocity of 72 kilometers per hour. So the initial velocity is equal to 72 kilometers per hour. You should know that your kilometer per hour is not the SI unit of velocity. So we would need to convert it to the SI unit. So converting 72 kilometers per hour to meters per second, it will be equal to 72, which is this 72 times 1000 divided by 3600. So this 0 will cancel out this 0, this 0 will cancel out this 0. 72 times 10 will give me 720 divided by 36. So this will be equal to 720 divided by 36 is equal to 20. So this is 20 meters per second. So our initial velocity is 20 meters per second. So a car accelerates uniformly at 5 meters per second square. Acceleration is equal to 5 meters per second square from an initial velocity of 72 kilometers for 10 seconds. So my t is equal to 10 seconds. Find the final velocity. Find the final velocity. So my final velocity v is unknown, is what I'm looking for. So from this question, I have acceleration, I have initial velocity, I have time, and I have velocity. So the equation of motion that connects these four parameters is the first equation of motion. And the first equation of motion is V is equal to U plus AT. So my V, which is the final velocity, is what I'm looking for, is equal to my U, which is the initial velocity, is 20, plus my acceleration is 5 meters. So A is 5 meters per second square, times my time is 10 seconds. So times 10. So my V will be equal to 20 plus 5 times 10 is 50. So 20 plus 50 is equal to 70. So my V is equal to 70 meters per second. This is our answer to this question. So our answer is correct, 70 meters per second. Thank you very much for listening.